Now we'll have just a brief look at drawings for power distribution. More just an overview and an intro. Here is a table of symbols from our textbook, if you happen to have the textbook by Madsen. There are two pages of them here. So these are symbols used in power distribution, and the electrical and electronic drawing standard is ANSI Y32.2. I believe that's where these are taken from. And some of them might begin to look a little familiar. So you see various variations on this same sort of shape, a thing that looks like a switch, and it's represented by a contactor that pivots up for the switch to be open or off, and then it could pivot down to make contact so the switch would be on. And then here are a number of line symbols. There are several different types of power distribution drawings. I think you could say going from bigger to smaller. We'll look at a few single line diagrams where the drafter just shows the big components that go into an installation, especially a power station or a substation. And the diagram you see on this slide is the one that we looked at in our worksheet. We'll also look briefly at power riser diagrams, which are a little bit more local. And then we'll look briefly at schematic diagrams, which we'll talk about more next time. People use these drawings to install, so the electricians might get out and use this schematic to figure out what gets connected where. When they're in the bidding process, they also use it to bid, and then of course they will need this when they have to go out and do troubleshooting. One thing you will notice about electrical drawings of all types is that they are not to scale. And in fact, they are not representative either. This is not what a fuse actually looks like. This is a symbol. This is not what a transformer actually looks like. This is a symbol. So the diagram or schematic is just showing where the electricity flows and how things are connected, with no hint of how big they are or how far apart they are. Here's a diagram for a substation. Here is where line voltage is coming in from the transmission lines into the substation. Recognize that symbol? That's a transformer. And here are this is a step-down transformer, 69,000 volts coming down to 4160 volts. This symbol right here that looks a little like a diameter symbol, but it has a little line straight up and down. That's the Greek letter phi, P-H-I, and that symbol stands for phase. So this is saying these are three-phase lines. Here's a residential line, which we've seen comes in at 240. Down here is an industrial or commercial line, which comes in at 480. Here's another single line diagram. This is a section of a substation. Here is a single line diagram of a substation. And if you gaze at this for a little bit, you start to recognize symbols that you know. For example, here on the right, the middle on the right, there's a transformer. What else do we know? Some things maybe we don't know the symbols yet, but we can begin to figure them out. There's a thing that says OL. That probably stands for overload. Well, in fact, it does stand for overload. Here's a symbol over here that we haven't learned yet, but it says CB. That must be a circuit breaker. So you can begin to pick out what these things are. And then up here on the upper left, there are a couple of switches of some kind, and we'll have to read the description to find out just what kind of switch they are. This is a small substation from Lane Electric Co-op, which is a electric utility that serves a lot of rural areas outside of Eugene, Springfield. This one is the Rainbow substation or switching station, and that's up the Mackenzie, up beyond Blue River. So you can see here are some switch symbols and some fuses. There's a transformer and a lot of labels. Oh, and one other symbol up here at the top, the ground symbol. And here are some grounds. Here's a drawing that's bigger than one substation. This is a place in Nebraska showing how a larger system divides into substations. So this gives us an overview, and we might now have a separate drawing for each of these substations. Now, a power riser diagram gets a little bit more local. It might look at a system in a commercial building, like a college or an apartment building. Here at the top is a pictorial drawing of a generator system. So this is what the building would use if the power goes out. And then here at the bottom is a diagram for that same system, just showing how the connections come off of the components. Here's another power riser diagram. This is a small one. And these also come with a list of what exactly are the parts. That's called a schedule. Here are a couple of other power riser diagrams. The one in the lower left corner is for a college building. And then coming down to a little bit more local scale. Here on the left is just a single line diagram that shows generally how a motor control circuit is connected. Here on the right is more detail in a thing called a ladder diagram. So this whole thing here is what we're going to look at next week. This thing here is a motor, and then we have various kinds of fuses and overloads, start and stop switches, and so forth. And this is all for the purpose of controlling this one three-phase motor. And you can see it's three-phase because there are 3 lines coming in at the top, and there in small letters is 3-phi, three-phase. Finally, these are kind of random, but I'm just showing you some various drawings from Lane Electric Co-op. And a few years ago, a drafting student from the program, actually 2 different drafting students, worked for Lane Electric Co-op. This student happened to be a technical illustrator, and so they were excited about that, and they asked her to make some representational drawings for their line workers. So here's a drawing of a repeater and a list of parts. This is very useful for people doing installation and troubleshooting. Here's another view of that repeater on a pole. Here's a conventional transformer. And down in the bottom, a schematic showing a little bit about how the lines are coming in. Some drawings showing exactly how to connect the guy wires for stabilizing the utility pole. And I'm not sure why they made these, but here are some parts, surge arresters and so forth. These are for underground connections. And then finally, here is a combination of some technical illustrations for use by the line worker, and then up in the upper left corner a schematic showing how the wires are connected. So notice the technical illustration looks to scale, the schematic not to scale at all. Next week, we'll talk about motor control circuits.